I want you to think about something today that is super confusing, and we're going to actually think about real situations, like actual problems that we can sort of say, okay, is this true or not true? So if you're stuck on how to get started, I'm going to show you how to get started. This is the process that I use with all my students, and I think by the end of this, you'll know what to do. So, all right. Integers are either closed or not closed under addition, under subtraction, etc. So there's a lot of stuff going on here, a lot of words, vocabulary that we want to think about. So the first one I would say is like, what are integers? So integers are negative numbers and positive numbers and zero, right? So if I want to think of like lots of integers, negative 1,005 is an integer, 27 is an integer, negative 31 is an integer, 2 is an integer. Like any positive and negative numbers that are just plain old numbers, we would call them, we might say natural numbers, whole numbers. Those are all kind of included, but just it's just a number, right? But it can be positive or negative. The light keeps changing. I'm right in the sunshine this morning. So um, those are integers. So think about when you have a question like this, are integers closed or not closed under addition or whatever the action is that you're doing the operation. All this means is like you take whatever's listed here first. So in this case, these are all about integers. And think that this is the entire pool of numbers that we can choose from for our answers as we go through this. So for addition, let's just think about addition, like 3 plus 2. Those are integers. The question is, do we get an integer for an answer? Well, we get 5. Yeah. 5 is an integer. It's a positive, plain old number, right? 1,000 plus 100 equals 1,100, 1,100, right? Those we started with integers and we ended with an integer. The answer is still an integer. Even if we did like negative 5 plus negative 2, well, we get negative 7. That's an integer. So we would say integers are closed under addition because we have this closed in amount of numbers to choose from. I'm trying to like connect it to give you a reason to remember that it's closed. It's like this closed set that we're choosing from. And yeah, the answer is in that set. Okay. So now let's think about what if we were going to subtract these numbers? Do we still get an integer? That's the question. So if we subtract these numbers, 1,000 minus 100 is 900. Yes, that's still an integer. 3 minus 2 is 1, still an integer. Negative 5 minus negative 2, that's negative 5 plus 2, which is negative 3, which is still an integer. We could try some other negatives just to make sure. But yeah, if we start with integers, positives and negative numbers, and all we do is subtract them, we're going to end up with more integers. So still closed. Still works there. Okay. Let me erase. Oh, not everything. Some of my work here. All right, now we're going to multiply. So let's just do some new numbers. So if we start with integers, positive and negative numbers, and we multiply, let's see here. 3 times 5 is 15. Negative 3 times negative 5, that's positive 15. So those are 15 and 15 are both integers. Let's see. Positive 3 times negative 5, that's negative 15. That's an integer, so that's good. What else? What have I not done? I've done both positive, both negative. Okay, negative 3 times positive 5. That would be negative 15. So I've kind of rearranged all the positives and negatives, and every single time I just end up with another integer, another positive or negative number. So integers are closer to multiplication. All right, so far so good. We are batting 1,000 so far. Now let's divide. Let's see. Um, we can use the numbers we just used. 15 divided by 3 is 5. That's an integer. And 15 divided by negative 3 is negative 5. What if I did 5 divided by 3? 5's an integer, 3's an integer. But if I divide 5 by 3, I get 1 2/3 or 5/3, right? I get fractions, which are rational numbers, but they are not integers. And if you can come up with even one example that doesn't work, then that is enough to say this is not closed under division. So that is why integers are not closed under division, is because you can get a fraction or a decimal depending on how you compute it. But fractions and decimals are not integers. But with it, adding and subtracting and multiplying, if you start with integers, you're going to end with integers. You're just going to end up with more whole positive or negative numbers. So I hope that helps you to think through why it works with those, but doesn't work with division. You only need one counter example. In other words, one example where it doesn't work to prove that it is not closed. I'll see you in the next one.